So today we're going to use the converse of the statements that we have been using before. So before we would say, if the lines are parallel, if I started out knowing that the lines were parallel, then I could say that corresponding angles, alternate interior angles, alternate exterior angles are congruent. And I could say that the same side or consecutive interior angles are supplementary. Today we're going to use the converse, the if Q then P. So those statements say if corresponding angles are congruent, the interior angles are congruent. If alternate exterior angles are congruent, then the lines are parallel. And they also say if same side consecutive interior angles are supplementary, then the lines are parallel. Okay, so the difference is what you know to begin with. Before, I knew that the lines were parallel, therefore I could find out information about the angles. This time, I know information about the angles, therefore I can find out information about the lines. So what it's going to look like today is I'm going to give you a picture, I'm going to give you some information about the angles, and you're going to be asked to tell me which lines are parallel. Now I do want to make a point, get this to focus right here. It is important for you to note that vertical angles and linear pairs never prove that lines are parallel. We use them when we're solving problems about parallel and perpendicular, or parallel, but we don't have anything, they don't have anything to do with parallel lines. Remember that your vertical angles share a vertex, your linear pairs share a vertex, but none of these other angles do. Corresponding, alternate interior, alternate exterior, and consecutive interior, none of those share a vertex, and that's the big difference between them. So while we use them with parallel lines, they don't make lines parallel. In fact, look at this picture. There are no parallel lines in this picture. There are no parallel lines in this picture. Okay, so here's how this works. So look at these a little bit at a time, okay? So let's just start with the orange. So with the orange, I said that angle 1 is congruent to angle 3. So I went over here and I highlighted angle 1 and I highlighted angle 3. Then I extend. What I noticed is that line A is the transversal because it cuts across C and D. So we look and we determine, are the angles that I'm talking about, are they one of our top 4, our magic 4, right? So look at angle 1 and angle 3. They're on the same side of the transversal, but angle 1 is exterior and angle 3 is interior. That means they are corresponding. The theorem says if corresponding angles are congruent, then lines are parallel. So we're going to say then that line C is parallel to line D. Okay, then on the same picture we can take this, and we'll just do this in a different color so you can see the difference. Okay, so I'm going to highlight angle 7, so I traced angle 7, and then I traced angle 12, and then I extended my lines out a little bit so that I could see them. Once I could see where they were, then I could go, okay, I can see my transversal is line D. I can see that they are on alternating sides of transversal D. And so they are alternate interior angles. And we know that if alternate interior angles are congruent, like I said then, lines are parallel. Which lines? A is parallel to B. Now the good thing about these types of problems is like you literally can see which lines are parallel if you take the time to highlight them. Okay, so let's use this extra picture down here for number 3. So in number 3, I said 10 plus 11, angle 10 plus angle 11 equals, highlighted angle 10, and I highlighted angle 11, and then I extended my lines together so that I could see how they all connected. Now, since those travel along this transversal, right, they have 1 point and 1 point, they are on the same side of transversal B, and they are both interior. They are in between C and D. Because they are same side interior angles and they're supplementary because I said so right here in this problem, that means that if same side interior angles are supplementary, then the lines are C is parallel to D. Now in 4, the reason that it's none, so you can see that we said none, 10, and I just extended the lines out. Well, if you just look at the blue lines, you can see that visually, you can see that there are no parallel lines. Okay, but the reason that there are no parallel lines is because 13 and 10 are vertical angles. And vertical angles don't have anything to do with lines being parallel. It doesn't cause them to be parallel. Okay, and so we would say none. Based on just those two angles, we don't know anything about lines being parallel. And then lastly, we have angle 4 and angle 15. So here's angle 4 up here, so I traced it, and here's angle 15, I traced it. Then I extended the lines until they connected, extended them out because it makes it easier to see. And so then you look, these are on alternating sides of transversal D. D's the transversal this time. They're on alternating sides and they're exterior. And we know that if alternate exterior angles are congruent, which I said they were, then lines have to be parallel. And you need to look and see which lines. So A would be parallel to B. Okay? Now, let's look at another one that's a little more complicated. But again, if you will highlight, use the highlighter so that you can see what's going on, it makes it work a whole lot easier. So let's look at this based on the given, determine which lines, if any, are parallel. Write the letter of your choice. So in this one, AC is parallel to DF. Remember, we need 2 points to name a line. This one would be AD is parallel to BE. AE, this line, is parallel to BF, and D, none are parallel. Okay, so let's look at what this looks like then. So angle 9 and angle 7. So let me do this first. Let's set this up. So AC is parallel to DF. That's what this one's going to look like. AD is parallel to BE. That's what this one's going to look like. I'm just trying to give you a little bit of context so you can see where they are, where the names are coming from. And then AE is parallel to BF. So that way we can tell which ones are which quickly and easily. So let's go over here and let's label the ones that you were given. So it says angle 9 is congruent to angle 7. So you want to trace angle 9. Here's angle 9, and you want to trace angle 7. So I'm going to trace angle 7. So notice that if we extend those two, they're going to travel along that. That's your transversal. And then we have this line right here. We extend it out a little bit so we can see, and this line right here. So we're looking at angle 9 is congruent to angle 7. So this is my transversal. Right? It's the one that you would travel along to get from 8 to 9. That's my transversal. And so then the ones that ended up being highlighted were the yellow lines. That's AC and DF. So I would choose option A, AC and DF. Okay, so let's use this picture down here, 7, since we've kind of messed up and cluttered a picture. Let's use that one. So angle 2 and angle 5. Okay, so trace the sides of angle 2, and we're going to trace the sides of angle 5. Now, extend your lines out, and then see if they connect, which they do. This line, this side of angle 2 and this side of angle 5 ended up being the same side. So we want angle 2 and angle 5. If you look at those, you see that F shape. They are on the same side of the transversal, but one is in between the two lines and one is outside of the two lines. But we can see that these angles match, or these sides that run the same direction as the green ones, which is this one, which is B. So angle 2 and angle 5 are corresponding angles, and if corresponding angles are congruent, then lines are parallel. Okay? So angle 9 plus angle 8 equals 180. The measure of angle 9 plus the measure of angle 8 equals 180 degrees. So here's angle 9, and here's angle 8. So we're tracing it. We're going to extend our sides out so that we can see it a little bit clearer instead of it all being closed off. So we've got angle 9 and angle 8 equal 180. So there's my transversal, right? BF is my transversal. And so that They are on the same side. They're both on the right of the transversal. They're both in between these two lines right here. They're in between. And so they're supplementary. So they are same side and they are supplementary. And we said if same side interior angles are supplementary, then lines are parallel. Which ones? The ones that run like this, which matches our yellow angle, which matches option A. So we have option A. Okay, then we have this last one, 9. So angle 4, here's angle 4. Trace the sides of angle 4. Trace the sides of angle 10. Okay, so let's extend our lines out a little bit so that we can see it. So here's 4. We travel up that road to get, so we travel up BE. Right, so BE is our transversal. You can see that. We have said that 4 is equal to 10. And what I notice is that if this is my transversal, 4 and 10 are on alternating sides of the transversal. They are in between my lines. Those are in between those two lines. So they are alternate interior angles. And I can see that these two run the same way as these orange lines. So that would be option C. Now, just so you could see it, what if I gave you 7 and 8? If I gave you angle 7 and angle 8, then angle 7 and angle 8 are on this same transversal. They would look like this, right? Well, there are not. You don't see any lines parallel, right? That's a linear pair. So they don't cause any to be parallel, okay? So always be careful with that. Make sure you can actually see parallel lines. Extend your lines so that you can see them. Parallel runs alongside each other, right? They never intersect. So if I were like that, then you would say none are parallel. But in this case, all of them have some kind of parallel set. Okay, so this last one says find the values of x and y that would make AB parallel to CD and AC parallel to BD. So in order for that to happen, if we want these lines to be parallel, then what is that we want those two to be parallel, and we want these two to be parallel. Well, let's look at our options. So I'm going to travel along this transversal, so I'm going to use this angle and this angle, the angle at A and the angle at C. If I use this side as the transversal, so we're going to cover that up. Okay, because if I use these two, then I have an X and a Y, and I don't want to deal with that. So I'm going to start over here, and I'm going to look at that. Well, what I notice is those are on the same side of the transversal. They're both interior, and same side interior angles are supplementary. So you set that up. Part plus part equals 180. So this part, X plus 8, plus this part, 2X plus 22, is equal to 180. Same side supplementary, right? If same side interior angles are supplementary, same side interior angles equal 180, then the lines will be parallel. So now from here, it's all algebra. We're going to combine our like terms. These are both on the left-hand side, so we'll combine our like terms. 1x plus 2x is 3x. We'll combine these two also. 8 plus 22 is 30, equals 180. We need to isolate our variable. Okay, so we have to subtract 30 from both sides. You get 3x is equal to 150. Do the inverse, divide by both sides by 3, and you get that x is 50. So we know that x is 50. Now the question is, I'm asking for y. Well, in order to find out what y is, the same thing has to happen. Now, if I cover this up, if I want these two to be parallel, then these are on the transversal. Those are on the same side of the transversal. They're both interior. So those have to add up to 180. So you can do this a couple of different ways. I could say y plus 2x plus 22 equals 180. Or I could go ahead and find out what this is. 2 times x, we said x was 50. Everywhere in the problem, x is 50, plus 22. That means that this angle is 122 degrees. This angle right here is 122 degrees because that's what, when you substitute in that 50. So that's 122. So 122 plus the angle at y is equal to 180. So if we subtract 122 from 180, you get that angle y has to be 50. Okay, so you could have also said y plus 2x plus 22 is equal to 180 if that makes sense to you, but then you know that x is 50, so you have to plug it in. Either way, you're going to end up with this. Y plus 102 is equal to 180. So either way, you're going to end up with that. Okay, so in summary, it all comes back down to these things right here. If you have these relationships, if these angles are congruent, then lines are parallel, and if same side angles are supplementary, the lines are parallel. Vertical angles may be congruent, but they don't ever talk about parallel lines, and linear pairs are supplementary, but they never say anything about parallel lines. Everything comes back to that, and you need a good, bright highlighter.